objective today is to talk about word problems with equations with variables on both sides, and then start to review for the 3-1 to 3-3 quiz, which you guys have tomorrow. You will have an assignment tonight, but I... Okay, but I will post the homework answers on Blackboard, and I will remind you that at the end of class. So even though you have a review to do, you're going to start it in class, finish it for homework or at school today. I will post the answers on Blackboard, okay, since we have a quiz tomorrow, so you can check them, make sure you're okay. I will answer questions tomorrow when you come into class. So we'll start the quiz at 7:35 tomorrow, but I will answer any questions you have, okay, before that. All right. So any comments? What did you think about 1 and 2? Just curious. Alyssa? Okay, kind of easy. Emma, what did you think? Number 2 was harder? Okay. Mary?
One quick reminder to students conducting fundraisers involving...
Not too bad. Okay.
...take place
Emma H?
Those students who are involved with clubs or organizations where fundraising...
Okay, so number 2 a little harder. Justin?
Those items are not to be sold during school hours. Thank you.
Exactly. When you read them at first, you're like, what do I do? But when you realize there's variables on both sides, when you set them up, it should be pretty straightforward. Annalise? Okay, we're going to talk through that. Okay, so number 1, what 2 things were they talking about here? So this is how I typically start them. Adam? Okay, but be a little more specific. Like one side of the equation talks about something, the other side talks about something. Awesome. So we have you, and I'm just going to put friend, okay? One side talks all about you at a carnival, and the other side talks about friend at a carnival. So what represents you? So what's the side that represents you, Briar? Good. So 6 plus 12x. Awesome. What's the side that represents friend? Alyssa? Good. 20x. So if you break it down like that, one side talks about you, one side talks about friend. That should make it kind of a little more straightforward. Okay? If you don't need to do that with labeling, don't worry about it. Annalise, did you have a question? Yep. Well, actually, yes, each game and each ride. So how much the tickets cost. How much each ticket costs. I had to look at my work there. So yes. Okay, so after you solve, Zach, what did you get for your answer? Good. So it's equal to 75 cents. And if I had more room here, I would write that each game and ride ticket costs 75 cents. Doug? Okay, what? Okay, I want you to try to do it this way. Okay, because it's a little bit more organized and keeps it a little bit easier. Okay, number 2. So let's first talk about our number 2. What 2 items or subjects are we talking about? So one side of the equation is what, the other side is what? Justin, what's one side? What kind of cost of the library? Good. So cost of library copies. What does the other side of the equation talk about, Adam? Good. So home copies. So one side is how much library copies cost. The other side is how much it costs at home. Kind of an interesting comparison. Donatus, do you have a question? You have to buy an ink cartridge and you have to buy paper. You know what I mean? No. Even though you're making copies, I have my printer is also a copier. Like, it's not free because I have to pay for the supplies, but it could be cheaper than going somewhere else, and that's what they're trying to get us to compare here. So what goes on the side of library copies? So what represents library copies? Doug? So, good, 0.15x, and I would say 0.15 instead of just 15, so you know that it's 15 cents. Okay, what about home copies? Sean? Good, 200 plus 0.02, what has to go next to the 0.02? Good. And in this one, what does x represent? What does x represent, Jeremy? No, 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 no. What does X represent? Not the answer. Good. X represents the amount of copies. All right. Annalise, what did you get for the answer? That's okay. Tell us what you got. No, tell us what you got. No, no, no. Look at your. Did you write it down? Oh, okay. You were right. That's why I asked you to. Alyssa? Nearest copy. That's fine. And it was 38.5. So if you're rounding it to the nearest copy, I would round it up to 39. I left it like 0.5, even though 0.49. No, but the 4 rounds up to a 5. Oh, I see what you're saying, Charles. You're still going to round it down because you looked at the whole thing. Either way is fine. I'm not going to take off if you rounded it slightly off one way or the other. Yeah, and that's fine. So I'm going to leave it like that. If you leave it as 0.49 or the long one, that's fine as well. It does not tell us in the problem what to round it to, so either way is okay. So great job there. That's the amount of copies that's going to make library copies and home copies equal. Annalise? That's what I said. Yep, I just said that. Yep. Okay. Okay, questions on how to set up 1 or 2. You guys seemed like you did really well on this. Thumbs up, thumbs middle, thumbs down on just those 2 word problems. I'm just curious. The solving part was easy. It was the setup that may have been a little tricky. Okay. All right, number 3. Donatus, what did you get? Okay, so what do we put? If it's not solvable. Okay, you could do that. No solution is all I was looking for. You had 6 does not equal 5. You could have left it like that, but the conclusion is there's no solution. Okay, the second one. Adam, what'd you get? No. Emma H? Okay, you are correct. Emma H, can you tell me what you got after the first step? So after you distribute, tell me what you got so I can go through this one. After you distribute, tell me what you got. Like after the very first step. That's okay. That's okay. Doesn't matter. Okay, so at this point, you then, Emma H, after you combine like terms, just tell me one more step. Combine like terms. What'd you get for the next step? Wait, did you do 4 minus 36? Did you do all the steps in your equation, or did you skip some? Okay, what's 4 minus 36? Okay. Okay, what's 2 minus 30? Negative 2 minus 30, sorry. Good. Okay, so at this point, when you go to add 6t to both sides, they cancel. So as Emma H said, we are then left with negative 32 equals negative 32 because the t's cancel. Therefore, the answer is many solutions or infinite solutions. Be careful on that. Okay, Adam, are you okay with that one? Did you make a silly mistake? Okay. Annalise? Yep. Mm-mm. You do the opposite, so you have to add it. Yeah, it's a negative 6t, but then to move it to the other side, you add it. Yes. Yeah, this is negative, this one. Well, you just go look at this step. It's right at this step. There's a negative in front of it. Okay? Emma? Okay, don't do that. That's, okay, it's either true or false, but the answer is it's either no solution or many solutions. Okay? Justin? Yeah, so you kind of just did it in your head. You still put many solutions, right? Okay, that's fine. Okay, any other questions on the warm-up? Okay, let's go over homework, okay, and then we will start working on our review in class. Good job on the word problems. Remind me after we go over the homework, I want to come back to one more word problem with you guys, just in case I forget. Okay, so 2-4, I am going to read over these because I want to have time to do the part of the review in class. Okay, I'll wait till you guys get there so that you can check as I'm reading them. So 2-4 homework. It was the back of page 45. Okay, you ready? Okay, number 1 is 7. Number 2 is 9. Number 3 is -15. Number 4 is 3. Number 5 is many solutions. Number 6 is 5. Number 7 is no solution. Number 8 is 13. Number 9 is 7. Number 10 is no solution. Number 11 is 4. Number 12 is 8. Number 13 is many solutions. Number 14 is no solution. Did I have you go to, whoops. 15 and 16 would be helpful to have up here. 15 is 2. 16 is -9. 34 is 3. 35 is 14. Okay, I will go over anything you need me to. Hold on. Okay. Sean. Yep. Okay, I'll go over it. Emma. Okay, let me start with that one, and then Sean, I'll come back to yours. You got a -4 instead of a +4. Okay. Did everyone check your answers so I can move this? Brian, are you still checking? Okay. Okay, let me come over here, Emma. Okay, number 11, we have 6K minus 25 equals 7 minus 2K. Okay, so first move the K to the other side. Okay, Emma? So add 2K to both sides. So we have 8K minus 25 equals 7. Okay, and then add 25 to both sides. So you get 8K equals 32. And that's how you get +4. Okay? Okay. All right, Sean, let me do 16. Brian, are you okay if I move this now? Okay, 16. We have 2/3 A minus 3/4 equals 3/4 A. So, Sean, what did you do first on yours? I can do it the way that you kind of did it. The number. Wait. Before you do that, what do you need to do though? This is where I think you messed up. You define a common denominator. So I would change all of them to be a denominator of 12. Okay? So if you change them all to be a denominator of 12, this is 8, this is 9, this is 9. Okay? From there, then subtract this from both sides. Do you want me to keep going? Sure? Okay. I can keep going, yes. So minus 9/12 A, minus 9/12 A. This goes away. So we get -1/12 A minus 9/12 equals 0. Okay? And then add the number, which is 9/12 to both sides. Okay, so we have -1/12 A equals 9/12. And then at this point, multiply both sides by -12/1. which basically, yeah, you just get rid of the 12, and you're left with 9 times -1, which is -9. You're welcome. Adam? Okay. Annalise, do you have a question on this one? Yeah. Okay, Adam, I'll come right back. Okay, well, just like we do in class, I would find a common denominator. Okay, it's the easiest way to do it. Okay? In the future, we see fractions. Do what we did in class because it'll keep the math problem a little bit more simple. Okay? All right, Adam, what number did you say? 9? Okay, 9. Okay, 9, we have 4s minus 12 equals -5s plus 51. Okay, did you move -5s first? Do you have your work in front of you? Kind of. Adam, explain what kind of means. Oh, okay. So is your work kind of like scattered? Is that the problem? Okay. Okay. So are you okay? 9s equals 63, and then that's how you get 7. Anyone else on the homework? Sure? So easier than yesterday? Okay, raise your hand if you got all of those right. Just curious. Okay, raise your hand if you missed one. Okay, good. Missed 2. Okay, not bad. All right, flip to either a blank page in your notebook or a piece of scrap paper. I want to do one more word problem with you because I know you guys don't like these problems, and it's a good challenge. So it's a consecutive integer, but it's a multi-step word problem, not variables on both sides. So we're starting to mix up the different types of word problems. Justin? I agree. Yep. Yeah, they make problems to torture kids. All right, so let me read it, and hey, maybe you'll agree that it's a little bit easier the second time around. All right, so the last time we did this, we talked about consecutive even integers. We are now talking about consecutive odd integers. So it says consecutive odd integers are 1, 3, 5, 7, and so on. The sum of 2 consecutive odd integers is 104. Write and solve an equation to find the 2 integers. Let 2x minus 1 represent the first odd integer. Okay. If 2x minus 1 is the first odd integer, what's the next odd integer? Annalise? Good. 2x minus 3. Okay? You could do that as well. Okay? So 2x minus 1, they tell us, is an odd integer. Why is 2x minus 1 an odd integer? Alyssa, why? Awesome. 2 times anything is even, so if we subtract 1 from it, it's going to be odd. If we subtract 3 from it, it's going to be odd. If we subtract 7 from it, it's going to be odd. We could keep going. So both of these represent odd integers. You could also use, like Charles said, 2x plus 1. That's odd. 2x plus 3. That's odd. So there's a lot of expressions you could use to represent an odd integer. I'm going to use these because of how they worded the word problem. So let's set this up. We know that the sum of 2 odd integers, consecutive, add up to be 104. Is everyone clear on how we set that up? Jeremy? Yes. You can use this, or you can use 2x plus 1. You can use either one. I agree. I understand what you're saying, but we're still finding 2 consecutive odd integers. They're still going to be in a row next to each other. But it's not going to be the one right after. It's going to be the one before it, the order that we wrote them. I know what you're saying, but it still works. But you could also use 2x plus 1, like I said a couple minutes ago. Annalise? Okay, in regards to how this is an odd integer, is that what you mean?
So say that x was 7.
Okay. That they're in order, that there's two odd integers right next to each other. So here, instead of using 2x minus 3, you can also use 2x plus 1. You'll end up with the same answer.
But like in that way, when you do 2x minus 1 and 2x minus 3, could that be any odd number?
Yeah, but we have to solve for it. So we're going to find it, okay? So at this point, let's combine like terms. Doug, you with me? Okay, 2x plus 2x is 4x. Negative 1 minus 3 is negative 4, all equal to 104. If you haven't already, go ahead and solve for x and tell me what you get for x. When you get it, put your hand up once you get x. Briar, what'd you get for x? Close? Sean? 27. Briar, did you use the same expressions as us? Okay. Add 4 to both sides, you get 108. So 4x equals 108. 108 divided by 4 is 27. Okay, make sure you always do the opposite. Now, this is x. We need to find the 2 consecutive odd integers. Adam, how do we do that? Good. So what do you get for that one? Doug? 53. What do we get for the other one? Good, 51. All we're doing is plugging the x back into these expressions. So is 53 plus 51 equal to 104? Yep. That's why it didn't really matter which expressions you chose here. Like Charles said, 2x plus 1, 2x plus 3. That works too. Okay, as long as it represents an odd consecutive integer. Briar? Yeah, but that won't always work. On these like basic ones, it does work. But you're exactly right. Zach? I see what you're saying. Yep, that's a good shortcut as well. Good job thinking there. Annalise? No, it still works. Still work the same way. Kind of interesting how that works out. Emma? Who can answer that? What would the answer be? Emma H, what's the answer? Good. Why are these the answers? Yeah. They're asking us to find the 2 consecutive odd integers, Emma M. So you want to find the 2 consecutive odd integers that add up to 104. Does that make sense? Okay. Doug? Yes, you can. Okay, Doug. So we get 4x plus 4 equals 104. Ah. Yeah, that's... Oh. Okay, so the x value is different. Sorry, I had to think about that for a second. So, Doug, what's x? What's 100 divided by 4? Okay, so you get x is 25, but, bless you, when you put it back in for 2x plus 1, you get 51 and 53. Still get the same thing. So, again, this just proves if you use a different expression for the odd integers, you're going to get a different x value, but when you plug it back into these expressions, you're going to get these same values, 51 and 53. Mary?
Like technically, do 2x plus 100 as 1 and 2x plus 100 is.
Sure, if that's what you want to do, and make it painful for yourself by using big numbers. But yeah, you will still get the same numbers. The x value will vary. Yeah, that's why I said it didn't matter. Yep, it's kind of nice. Annalise? But that doesn't matter. Yep. All right, open up your book to, I'm going to give you guys a couple more word problems to practice. So, Sean? What we just did now? I would say notes. And actually, the word problem I just did with you, do you remember that the warm-up I gave you guys that had 4 word problems on the front, 4 word problems on the back? I gave you 2 days ago. That was number 5. So I actually did one from there. Hold on. So the stuff we just did, I would put it under notes, but that I actually got that from a worksheet you already have, which had word problems on the front and on the back. Okay, so there's 2 pages you're going to do. So the first one, pages 134 and 135. I want you to try number 27 and 32. They're 2 word problems. And then page 137, 1 to 17. So 19 problems, not bad. I am going to take a picture of this and put the answers up on Blackboard. The answers will be under the Chapter 3 tab. It will say 3.1 to 3.3 Review Solutions. Who can clarify what I just said? Because last time I did this, some of you guys didn't listen. What did I just say about the answers? Adam, what did I just say? Good. They will be on Blackboard. Why would I do that? Why would I do that, Alyssa? Yep, so we don't have to take time away for your quiz tomorrow, and also so you can make sure that you know what you're doing. In addition to this, anything is fair game. Those 3 word problems we did in class today, any notes we did, any fraction problems, okay? Some of them could be no solution or many solutions. So anything from 3.1 through 3.3. Okay, you will be able to finish in 1 period, but I just want to make sure that you are prepared, especially if you want to get your grade up a little bit. Alyssa? Just the quiz. Yep. The chapter test won't be for another week and a half or so. Yep, just a quiz. Remember, quizzes are smaller than chapter tests. Okay, Mary? I don't know yet because I'm still typing it, but it's not going to be as long as a chapter test. I'd say probably about 30, 35 points. Okay? At the most, probably 4. At the most. At the most. Zach? You mean tests? Yeah, tests are always worth that. Yep, they're always weighted. Emma M? Yes, you may. Okay, go ahead and get started. We have about 10, 15 minutes to get started. I will walk around to help you guys on whatever